Hello everyone and welcome to our channel, Moo Techie. A special welcome to all the dairy technologists and students joining us. This is class 3 in our dairy engineering series, where we continue our deep dive into Unit 1 on sanitation. Today we are moving from the equipment itself to the vital network that connects it all: sanitary pipes, fittings, glass piping, plastic tubing, and gaskets. The design and selection of sanitary process, piping and fittings are just as important as the dairy equipment itself because they are also product contact surfaces. The material must be stainless steel of grade 304 or 316. Milk flowing at high velocity can cause corrosion due to erosion and pitting. There are also special types of pipe fittings used for measuring the properties of milk. And finally, the surface finish of these pipes is extremely important for cleanability. A sanitary pipeline system is made up of several key components. These are the pipes themselves, the fittings that connect them, the valves that control flow, and special fittings for specific purposes. Now let's look at the principles for designing and laying out sanitary pipelines. Pipes should be seamless and preferably cold drawn to ensure a uniform structure. They should be softened, descaled, and pickled in an acid bath to remove impurities. They must be polished both internally and externally to a smooth finish. They need to be clean, smooth, and free from any surface defects. They must be straight and free from any longitudinal grooving, both on the inside and outside. The material for any fittings must be the exact same as that of the pipe to prevent galvanic corrosion. The condensate that forms on the cold surface of milk pipelines must not be allowed to drip onto places where it could create unhygienic conditions or contaminate milk. And the capacity of the pipeline must be designed to allow the milk to flow within specific velocity limits, without causing too much pressure loss. Let's talk about the pipes themselves and their specifications. Here is a table of outer diameters, thicknesses, and approximate capacities for standard sanitary pipes. A pipe with an outer diameter of 25.4 mm and a thickness of 1.25 mm has an approximate capacity of less than 2000 kg per hour. A 38.1 mm diameter pipe with the same thickness can handle less than 7200 kg per hour. A 50.8 mm pipe carries between 7200 and 15,000 kg per hour. A 63.5 mm pipe with a thickness of 1.5 mm handles 15,000 to 22,700 kg per hour. And a 76.2 mm pipe carries 22,700 to 36,000 kg per hour. When selecting a pipe size, you should choose the next larger size for heavy liquids like cream or ice cream mix due to their higher viscosity. Similarly, choose the next larger size if the flow is by gravity rather than pumped. The main criteria for final selection are achieving the correct flow velocity and managing cost. There are some general piping design considerations to always keep in mind. Keep all piping lengths to an absolute minimum to reduce cleaning costs and pressure drop. The piping layout should never be a hazard or create a restriction for the plant operator. All valves and instruments must be located so they are both easily operable and maintainable. The pipe layout should allow for adequate individual support and group supports wherever possible. And finally, the entire piping system must be designed to be completely drainable with few, if any, pockets where liquid can be trapped, and it must be provided with adequate drain valves. Sometimes glass piping is used as an alternative to stainless steel. The main reason for using glass is the valuable visibility it provides, allowing you to see the product flowing inside. The external piping must still be of a suitable metal for support. The glass used should not be of a type that splinters. Instead, a material like Pyrex glass, which is very tough, is used. Glass piping is commonly used as level gauges on tanks. It is also used as an inner liner for storage tanks or pipelines. Its normal operating temperature range is from 0 to 212 degrees Fahrenheit. For sterilization, you should use live steam or a chlorine solution, as thermal shock must be avoided. Another option is plastic tubing. Plastic pipes and flexible tubing, like the brand Tygon, are sometimes used. They have a lower resistance to temperature compared to metal. A common use is for temporary connections for tank-to-tank milk transfer. The temperature resistance varies greatly between plastic materials. This is a key factor in selection. PVC can handle up to 50 degrees Celsius. Polystyrene up to 65 degrees Celsius. Linear polyethylene between 60 and 90 degrees Celsius. Polypropylene between 70 and 100 degrees Celsius. And polytetrafluoroethylene or Teflon can withstand very high temperatures from 325 to 330 degrees Celsius. All plastic tubing must meet several requirements. It must be food grade. It should be light in weight. A smoother internal surface gives lower resistance to fluid flow. It must not impart any off flavors to the product. and it must have higher resistance to detergents and sanitizers. However, there are disadvantages to using plastic tubing. It is easily wetted by fats. This can cause fat to penetrate into the surface of the plastic. This fat is very difficult to remove, and if it is not removed, a rancid odor develops on the surface due to fat decomposition. The consequences include discoloration, crevice formation, irreversible distortions of shape, bacterial contamination in those fine crevices, and taints in the milk due to plasticizers leaching out from the material. Now, let's discuss gaskets. Gaskets are used to prevent leakage between two metal surfaces. They create a static seal. They are commonly made of rubber, Teflon, and sometimes even stainless steel. Different gasket materials have different heat tolerance limits. Nitrile butyl rubber or NBR is rated to 130 degrees Celsius. Butyl rubber to 140 degrees Celsius. Ethylene propylene or EPDM to 165 degrees Celsius. Silicone rubber to 175 degrees Celsius. Witten to 180 degrees Celsius. And perfluoroelastomer or FFKM can withstand up to 300 degrees Celsius. For the dairy industry, gaskets have specific requirements. They must be fat resistant to prevent swelling and degradation. They must be resistant to detergents and sanitizers. And they must be resistant to a certain degree of heat for cleaning and processing. Gaskets have many applications throughout a dairy plant. They are used in stainless steel pipe fittings. They are used as manhole gaskets on large tanks. They are critical components in milk pumps, cream separators, and homogenizers. And they are used in diaphragm valves. There are specific requirements for installing gaskets. To keep them in place, various methods are used. Blues, which are adhesive compounds, and gasket cements are used, but mechanical methods are more common and reliable. When using blues and cements, a special procedure is needed to fix the gaskets, and this sometimes limits their application at high temperatures. Stainless steel gaskets require high-tension bolting to form a proper seal. Finally, some important precautions for gaskets. They have to be stored in a cool and dry place to prevent premature aging. They should not be exposed to ozone, which can be generated by activities like electric arc welding, as it causes the rubber to crack and degrade. Thank you for joining us for this class on the veins and arteries of a dairy plant. Understanding the sanitary design of pipelines, from the choice of material to the humble gasket, is fundamental to building a system that ensures product safety and quality from start to finish.